In this particular video lecture, we will discuss a numerical question based on the concept of star and delta connection, whatever we have discussed earlier. Now, as you can see here, this is the question: a balanced a star connected load. The connection is basically a star connected load of 8 plus I6 ohm per phase. This is the value of impedance Z connected to a balanced 3-phase 400 volt, means the line voltage is 400 volt. And as we know, the in a star connection, VL means line voltage is root 3 times of phase voltage, and we know the value of line current is equal to the value of phase current, my dear friends. Now, as you can see here, what we have to calculate is to find the line current. We have to calculate the line current. We have to calculate the line current, and as we know, the value of line current and phase current is equal in case of a star connection, and it will be equal to, my dear friends, we can say V phase by Z phase. Its value will be equal to V phase by Z phase, and then we have to basically calculate the value of power and total volt ampere, means we have to calculate the basically the value of S. Now, as you can see here, this is the circuit diagram, you can say, and this is the value of impedance, and as you can see here, this is the line voltage. Line voltage is given here 400 volt, and this one is the phase voltage. And now, as you can see here, that in the given question, the value of VL is given as 400 volt, and if you and as we know, in a star connection, the value of VL is equal to root under 3 V phase. So if you want to calculate the value of a V phase from here, then it will be equal to the line voltage by root 3, and my dear friends, it will be equal to, as you can see here, 400 by root 3 volt. And now the value of Z phase is given here 8 plus 6J, and if you want to calculate the value of magnitude of Z phase, then it will be equal to root under the square of imaginary part plus the square of real part, and as you can see here, root under 8 square plus 6 square, and its value will be equal to 10 ohm. And now the first question is, we have to calculate the line current, and we know the line current and phase current is equal in case of a star connection. So we can use this formula, that is V phase by Z phase, to calculate the value of I phase, which is equal to line current. So as you can see here, the value of V phase is 400 by root 3, and the value of Z phase is 10, and it will be basically equal to, the value of I phase will be equal to 23.09 ampere. And my dear friends, as we know, the value of line current and phase current is equal in case of a star connection, so its value will be equal to 23.09 ampere. And now, as you can see here, the second question is basically, we have to, as you can see here, the first is to basically, we have to calculate the value of current, and the second one is we have to basically calculate the value of power factor, power, and total volt ampere. My dear friends, VA, volt ampere, and it is the unit of, we know, S, that is ampere and power. So now we will proceed to calculate the value of power factor, and as we know, this is the basically the value of Z, and we know that this one is the real part and this one is the imaginary part, or we can also say that we know that the real part lies on the x-axis, so this is the value of x-axis, and this one is the value of y-axis. So as you can see here, this one is the x-axis and this one is the y-axis, so we have noted here at 8 and 6. And now if you want to calculate the, as you can see here, this is a right angle triangle, and if you want to calculate the value of hypotenuse, then it will basically equal to 10 by the use of Pythagoras theorem. And now from here, if you want to calculate the value of cos phi, then it will be basically equal to 8 by 10, and it will be equal to 0.8. So we calculated the value of cos phi, that is power factor. And now we will calculate the value of power. Now as you can see here, we know that the value of power is equal to root under 3 VL IL cos phi, and we know that the value of VL is 400, and the value of IL is 23.09, and the value of cos phi, that is power factor, is 0.8, and the value of power will be equal to 12797.78 watt. And now, my dear friends, we have to basically calculate the value of VA, means volt ampere, and as we know that the value of ampere and power, that is S, its unit is basically volt ampere. So here we also know that the value of S is equal to, my dear friends, root under 3 VL IL. Now my dear friends, as we know the value of ampere and power, that is S is equal to root under 3 VL into IL, And as we put all this value into this formula, then the value of apparent power will be equal to 15997.22 volt ampere. So my dear friends, that it's for the video. I hope you have enjoyed this video. Now in the next video we will discuss the next unit, that is unit 4. That's all. Thank you.